SpaceX just lost their only Starship test facility in a catastrophic explosion. Their solution? Something that's never been attempted before. They're retrofitting their $3 billion orbital launch tower, designed for massive super heavy boosters, to test delicate Starship upper stages. Think about this. A tower built to handle 33 Raptor engines is now being jury-rigged with manual fuel lines for single spacecraft testing. Here's the insane part. One miscalculation destroys their only remaining launch capability, but they're doing it anyway. Why? Because waiting 3 to 4 months for repairs could kill their Mars timeline completely. The explosion debris may have crossed into Mexico, sparking international tensions. Ships 37 and 38 are sitting ready. Every day costs millions. Will this unprecedented engineering gamble save SpaceX's program or destroy it entirely? Let's dive right in. Ship 36 sat on the Massey's test stand, fully fueled, engines primed for what should have been routine testing. Then in a split second, everything SpaceX had built for Starship testing vanished. The explosion wasn't just violent, it was complete annihilation. The blast obliterated their only facility capable of testing Starship upper stages. Not damaged, not delayed, destroyed. Here's what makes this crisis different from every other SpaceX explosion. This wasn't another prototype lost in development. This was their entire upper stage testing capability, gone in seconds. Without Massey's, every single Starship becomes a billion-dollar paperweight. The damage assessment hit like a second explosion. 3 to 4 months minimum for repairs. That's not just time lost. That's the difference between reaching Mars in this decade or watching China get there first. Ships 37 and 38 sit ready. Billions invested, engines installed, but nowhere to prove they work. Every day of delay costs millions. But more terrifying, it threatens SpaceX's entire Mars timeline. So what does Elon's team do when facing their biggest crisis yet? They attempt something no aerospace company has ever tried, something that could save their program or destroy it completely. The orbital launch mount wasn't designed for this, not even close. Think of trying to use a massive industrial crane built for lifting cargo ships to delicately place a wedding cake. The engineering challenges are staggering, but SpaceX doesn't wait for committees. Within hours of the explosion, crews start cutting steel. They slice away angled bracing on transport stands, reshaping them to fit within the OLM's central opening. But that's just the beginning of this engineering madness. Next comes the brutal part. They remove all 20 super heavy hold-down clamps. These aren't just bolts. They're massive mechanical systems designed to restrain 16 million pounds of thrust. Each clamp weighs thousands of pounds. Each removal creates new structural vulnerabilities. Here's where it gets truly insane. The fluid systems. Super heavy boosters use the BQD, Booster Quick Disconnect. This massive umbilical pumps thousands of gallons of propellant per minute at crushing pressures. But Starship uses the SQD, Ship Quick Disconnect. These systems are completely incompatible by design. SpaceX's solution? Engineering madness. They're bypassing the BQD entirely, manually routing separate propellant lines directly to the ship, hand-connecting high-pressure fuel lines that normally operate through automated systems. One wrong connection, one pressure miscalculation, and they lose everything. But wait, there's more. The software controlling these systems was calibrated for Super Heavy's massive fuel requirements. Starship's tanks are smaller, with different pressure tolerances. The entire control system needs recalibration to prevent overpressurization that could destroy the vehicle before testing even begins. Tuesday evening, venting was observed from the launch mount. This wasn't routine maintenance. This was SpaceX testing their jury-rigged propellant delivery system. Each puff of vapor represents hundreds of thousands of dollars in testing, validating that their impossible modification might actually work. Here's what the public doesn't understand about this modification. It's not just about connecting different pipes. The fluid dynamics are completely different. Super Heavy requires massive flow rates, like opening a fire hydrant at full blast. Starship needs precision flow control, like filling a champagne glass without spilling a drop. The pressure differentials alone could be catastrophic. Too much pressure and the Starship tanks rupture like a balloon. Too little and the engines won't ignite properly. SpaceX engineers are performing surgery on a system designed for brute force, trying to make it delicate enough for precision work. Every connection point becomes a potential failure. Every seal, every joint, every valve must work perfectly. The cryogenic temperatures make everything brittle. Liquid oxygen at -300 degrees Fahrenheit doesn't forgive mistakes. The cryogenic proof testing comes next. They'll flood the system with liquid oxygen and methane at temperatures that would freeze your breath solid. Checking every joint, every seal, every connection. One failure here, and the entire orbital launch capability is at risk. But here's the twist that changes everything. This isn't just about testing ships 37 and 38. This is about proving SpaceX can adapt their infrastructure faster than anyone thought possible. If successful, it demonstrates a level of engineering agility that could revolutionize space operations forever. While SpaceX fights to save their testing capability, a diplomatic nightmare erupts across the border. The Ship 36 explosion was so powerful that debris crossed into Mexico. Not just a few fragments, potentially thousands of pieces traveling at supersonic speeds. Mexican President Claudia Sheinbaum didn't just express concern. She declared war, legal war, threatening action for environmental damage from debris crossing international boundaries. This isn't just bad PR. This is a potential violation of international environmental treaties that could shut down Starbase entirely. The blast radius calculations are terrifying. Fragments traveling faster than bullets could have covered miles beyond the designated safety zones. Mexican authorities launched a full environmental investigation, reviewing soil samples, air quality measurements, ecosystem impact assessments. SpaceX's response reveals the true gravity of the situation. They're not just offering cleanup assistance, they're prepared to allocate additional resources for environmental monitoring. Translation, they're willing to spend millions to prevent legal action that could destroy their entire Texas operation. But here's the question keeping SpaceX executives awake at night. If Mexico succeeds in legal action, could it force environmental impact reviews for every future launch? The precedent could cripple not just SpaceX, but America's entire commercial space program. Unauthorized trespassers complicate debris recovery, people crossing into private property, hindering cleanup efforts, potentially destroying evidence that could prove or disprove environmental damage. Every day of delay gives Mexico more ammunition for legal action. Ship 37 sits in Mega Bay 2, engines being installed while SpaceX races to complete their orbital launch mount modification. Every day of delay costs more than money. It costs momentum in the space race where second place means irrelevance. The timeline is brutal. Ship 37 needs engine installation, then transport to the modified OLM for static fire testing. Meanwhile, Ship 38 requires cryogenic proof testing on the same mount before returning for its own engine installation. It's a complex choreography where one mistake ruins everything. Booster 16 already completed its testing, sitting ready for Ship 37. But Booster 15, the same vehicle caught by the tower arms during Flight 8, needs reconfiguration back to its standard setup after the Starship testing concludes. Here's the engineering ballet that could make or break SpaceX's timeline. Modify the OLM for Starship testing, test Ship 37, reconfigure back to booster configuration, test Booster 15, then modify again for Ship 38. Each reconfiguration takes weeks and costs millions, but SpaceX believes they can achieve something unprecedented. Launching Flights 10 and 11 within weeks of each other. If successful, it would demonstrate operational cadence that competitors can't match. If it fails, they lose their only remaining launch capability. Behind all this crisis management lies a bigger strategy. Ships 37 and 38 represent the end of Block 2 Starship design. Block 3 is coming, more powerful, more capable, but requiring completely different testing protocols. The Massey's rebuild isn't just about repairing damage. SpaceX is upgrading the entire facility to handle Block 3 testing requirements. New flame trenches, upgraded propellant systems, enhanced safety protocols designed for vehicles that will be 30% more powerful than current Starships. Launch Pad B construction accelerates in parallel. 20 booster hold-down clamps are being installed. Dual BQD systems integrated. Flame trench steel plating applied. The tank farm receives new propellant pumps and cryogenic vaporizers to support dual pad operations. If current progress continues, Pad B could be operational within months, providing the redundancy SpaceX desperately needs. No more single points of failure. No more engineering crises that threaten entire programs. But here's what makes this moment critical. SpaceX is betting everything on their ability to adapt faster than problems can destroy them. It's a philosophy that's worked before, but never under stakes this high. Let's talk about what happens if this orbital launch mount modification fails. SpaceX loses their only remaining launch capability. Ships 37 and 38 become expensive static displays. The Mars timeline slips by years, not months. The risk calculation is staggering. They're betting their entire Starship program on an engineering modification that's never been attempted. The pressure tolerances, flow rates, control systems are all operating outside design parameters. One overpressurization event, one control system malfunction, one structural failure, and the entire orbital launch infrastructure is destroyed. Game over. Yet SpaceX moves forward because the alternative is worse. Waiting for Massey's repairs means losing momentum in the space race. China's space program isn't slowing down. NASA's Artemis timeline isn't extending. The window for Mars missions in this decade is closing. But here's what makes this different from typical aerospace conservatism. SpaceX has proven that rapid iteration works. They've turned failure into data, explosions into learning experiences. This modification represents the ultimate test of their engineering philosophy. The venting observed Tuesday suggests initial testing is proceeding, but static fire testing requires perfect execution. Every system must work flawlessly. Every connection must hold. Every calculation must be precise. This crisis reveals something crucial about modern space operations. Single points of failure are program killers. SpaceX learned this lesson the hard way. One explosion eliminated their entire upper stage testing capability. But their response demonstrates unprecedented engineering agility. Traditional aerospace companies would spend months in review committees, analyzing risk matrices, conducting feasibility studies. SpaceX started cutting steel within hours of the explosion. This speed comes with risks. The modification bypasses safety systems, operates equipment outside design parameters, relies on manual connections where automated systems failed. But it also demonstrates capabilities that could revolutionize space operations. If successful, this modification proves that launch infrastructure can be rapidly reconfigured for different missions. Today it's Starship testing. Tomorrow it could be satellite deployment, space station construction, Mars mission preparation. The question isn't whether this specific modification will work. The question is whether SpaceX has demonstrated a new model for space operations, one where adaptation speed matters more than perfect reliability. Every day of delay in Starship testing pushes Mars missions further into the future. The planetary alignment windows are unforgiving. Miss the optimal launch window, and you wait 26 months for the next opportunity. SpaceX's Mars timeline depends on proving Starship reliability through extensive testing. Ships 37 and 38 represent crucial steps in that validation process. Their successful testing unlocks the next phase of Mars mission preparation, but this crisis also reveals the fragility of Mars ambitions. One explosion, one diplomatic dispute, one engineering failure, and humanity's multi-planetary future hangs in the balance. The orbital launch mount modification is more than an engineering solution. It's a statement that SpaceX will not let infrastructure limitations delay humanity's expansion to Mars. Whether that ambition outweighs the risks, we're about to find out. This unprecedented engineering gamble will determine if SpaceX's philosophy of rapid iteration can survive its ultimate test. Success means Mars missions stay on track. Failure means years of delay, and watching competitors claim the red planet first. The next few weeks will reveal whether this insane engineering fix saves SpaceX's program or destroys it entirely. So here we are. SpaceX just bet everything on an engineering solution that's never been tried before. They're retrofitting a $3 billion launch tower, manually connecting fuel lines, and racing against time while Mexico threatens legal action. But here's what this really tells us about the future of space exploration. We're witnessing the birth of a new philosophy where speed trumps caution, where adaptation matters more than perfection. Traditional aerospace would still be in committee meetings. SpaceX is cutting steel and testing systems. It's either brilliant or completely insane. What do you think? Are we watching SpaceX save their Mars timeline or destroy their entire program? Drop your thoughts below, and if you want to see how this engineering gamble plays out, hit that subscribe button. Because when SpaceX tests this modified system, you'll want to be here first. The next few weeks will rewrite the rules of space engineering. The question is, will humanity's path to Mars survive the rewrite?